actually work. Thanks. All right, so for Pythagorean theorem, the basic idea of Pythagorean theorem is it's a process or the formula that is used to be able to describe how the legs of a right triangle are related to the hypotenuse of a right triangle. And so we're going to talk about those keywords in a second as well. But go ahead and get the definition down. And as a bunch of you have already stated, you already know what the Pythagorean theorem's formula is, that a squared plus b squared equals c squared, which is great. I'm glad you guys know it. But you do want to make sure that just knowing it doesn't mean that you understand how to actually utilize it and how it can be related in multiple facets. Okay? So, again, it's going to describe the relationship between the legs, and for that I'm going to go ahead and put legs in parentheses. That's the values A and B. That's what we call them. And the hypotenuse. And that's the value that we label C. And it's only of a right triangle. This is only going to be true for right triangles. If it's not a right triangle, you cannot utilize this formula. Okay, so basically you have any type of right triangle. It doesn't matter how big or how small, as long as it's a right triangle. And when we talk about the legs, the legs are going to form that right angle. So that's really important to make sure you understand. The legs are the values that are going to be forming that right angle. And the hypotenuse is the value that is directly across from the right angle. Okay? Whatever value is directly, or the line, the measurement, the side measurement that's directly across from that right angle, that's the one that's considered to be the hypotenuse. And also, key thing to remember about the hypotenuse is it's the largest side. It's the largest measurement of the right triangle. So you want to make sure you put that down. The hypotenuse is the largest measurement. Okay, and then from here you have your formula, a squared plus b squared is equal to c squared. So knowing those perfect squares, knowing what your squared values are and your square root values are, it'll make this unit go a lot faster. All right, so let's say that we have a triangle like so. And we'll say that this is 9 inches, and this is 12 inches. And that's all we know about it. And I want to figure out what the perimeter is. I want to know the perimeter. Well, in order to do the perimeter, we need to know what? We need to know C, right? We need to know the measurement of this hypotenuse here. Because in order to do perimeter, perimeter is the measurement of the sum of all 3 sides, right? But we only know 2 of the sides. So we have to find that third side. Because it is a right triangle, we can use our Pythagorean theorem to be able to solve for that missing measurement. Okay, so like was already mentioned, the hypotenuse C is the value that is missing. That means that 12 inches and 9 inches are going to represent those legs. Doesn't matter which one's A and B? No. Doesn't matter at all. So I'm going to go ahead and just label this one A. I'll label this one B. Does not matter which one's A and which one's B. Okay? What does matter, the only one that is important, is that you label C correctly. Okay, so I know that A is going to be equal to 12. That B is going to be equal to 9. And C is the value that is missing. So now we just plug it into our formula. We've got the A squared plus B squared is equal to C squared. So instead of A squared, we're going to put 12 squared. Instead of B squared, we're going to put 9 squared. And then that's still set equal to C squared. All right. 12 squared, what is it? 144. Very good. 9 squared? 81. If I add 144 and 81 together, what are we going to get? 225. So now I have 225 is equal to C squared, but I don't want C squared, I want C. So who remembers what is the inverse operation to an exponent? Ian? The square root, or a root. Whatever your exponent is, if you take its converse root, then you will be able to do the inverse operation. So if it's a square, you take the square root. If it was a cube, you do the cube root, and so on and so forth. Okay, so if you need to write that down as a reminder that a square root is the inverse of square. So if I take the square root of 225 and the square root of C squared, I now have the value of C by itself. What is the value of C going to equal? 15, right? Because that square root of 225 is 15. So now I know the measurement of C. But the question was asking what?
The perimeter.
The perimeter. So what do I need to do now?
Plug in C.
Plug in C and add it, right? We're going to add them all together. So for my perimeter, I'm going to be adding the A value, which was 12, the B value, which was 9, and now the C value, which is 15. So what is my perimeter? Good. And don't forget your unit of measure, so it's inches. So the perimeter is 36 inches. Bless you. Yeah. Hmm? No. No. Not yet.
Wait, not yet.
Not this year.
Okay.
You guys are so funny. By the time you guys get into calculus, you're going to be looking at this class and going, oh my God, this was so easy. And then any of you who continue on with math, and you're going to get into, you know, the absolute algebra, abstract algebra. Abstract algebra. So you guys right now, you are doing concrete algebra. So, or computational algebra, things that can actually have number values. You're actually solving for something. It's concrete. Abstract algebra is all proofs, stating things like, hey, the measurement of AR is equal to the measurement of CR, and the measurement of BR is equal to the measurement of DR. Using geometric proof, prove that AR plus DR is the same thing as CR plus BR. But it's without using values. You're not using numbers. You're having to use actual proofs. So abstract out, and that's a simple problem. That's a very, very simplistic problem. And abstract algebra, you know how Arhan was asking the other day, he's like, why did we use the value pi? Pi being a Greek letter. The whole Greek alphabet, like you use gamma and lambda, you're using all of that in abstract algebra. The Greek alphabet. The Greek alphabet. Alpha, beta, like gamma, lambda, delta, but it's all wonderfully orchestrated. Aren't you Greek? Are you Greek? Yeah. So you know what I'm meaning when I'm saying that the fun. All right. Shh. But not everybody's going to go into a strong math field, and that's okay, guys. All right. Let's say that we have a problem here. Don't say no.
That's not defined. I don't like.
I don't like anything.
All right. In this problem, I want to find the area. I want to find the area. Now, shh. To find the area of a triangle, who remembers what the formula is for area of a triangle? Hold on. Shh. Quiet. Raise your hand. Think about it for a second. We're talking of a triangle, and I want the area formula. Give you a couple seconds to think. We watched a whole video on it. I should see a lot more hands than what I'm seeing. It's kind of sad and disappointing. Miles.
Area times base times
No, what? No. Give me.
Hot. Let's try again, Miles. Yeah. So base times height, and then you take half of it, right? So base times height divided by 2, or half the base times the height. Do we know the base? No, we don't. The base value is right here. That's the value that is missing. Do we know the height? Yeah. Which one's the height? The 5 or the 3? The 3. Okay, so the 5 isn't necessary for the formula for the area, but the 5 is necessary in order for us to be able to find what the base value is going to be. Yes?
That triangle is a right triangle, so that means it's half of a square. So that means the 3 is going to be the same as...
We don't know the base though.
What if it's a rectangle? The base exactly. It's a right rectangle.
It doesn't mean anything. It can be
Shh. Hold on. Let him talk. Give him a second.
It's a triangle.
It is a triangle.
If you put it like together, you know,
Uh-huh.
like the 3 for like the side thingy is going to be the same for the top thingy.
No, it's not. Only if it was a square. This is not a square. So see, the thing is, you can automatically tell that this is not going to be an isosceles triangle, meaning that these two measurements are the same. Because if it was an isosceles triangle, our hypotenuse would be an irrational value. It would be an actual radical and not a whole number. In order for us to create a whole number for our hypotenuse, we have to have rational and we have to have scalene values for our triangle. If they were identical, you would get a radical number for your hypotenuse. But we don't have a radical number. So it's a very good thought, and that does exist sometimes, but that's only true if it's a square that this is cut into. Remember, all triangles are just taking any parallelogram and slicing it or not parallelogram, any quadrilateral and slicing it into two. Okay? All right. So what we're doing here is we're going to plug it into our formula. So we know that the 3 is one of the legs. Does it matter if it's A or B? No. We'll go ahead and make it a B value. And the other leg is going to be the A value that's missing. And of course the 5 is our hypotenuse, that's our C. Okay, so A and B can be switched around. C has to be the hypotenuse. So A we don't know. B we know is 3. C we know is 5. So now when I create my formula, my A squared plus B squared equals C squared. I'm just plugging everything in. I don't know the A, so it stays A squared. But I do know B. B is 3, so it now becomes 3 squared equals C squared now becomes 5 squared. Okay, so what is 3 squared going to give me? 9. So we have A squared plus 9 is equal to, what's 5 squared? 25. Okay, so now we have the following situation here. What do I do to solve that? Aristea. Subtract 9 from 25. So you're subtracting the 9 from both sides, and you're going to get that A squared is now equal to 16. So now we have to do what? Akshaya? Find the square root. We have to take the square root, and we'll get that A is going to be equal to 4. Okay, now I asked for area, so now what are we going to do? 4 times 3 divided by 2. Good, because area is going to be your base measurement times your height measurement and dividing that by 2. Well, in this case, we know that our base happens to be the measurement of A, which is 4. And our height happens to be the measurement of the B, which is 3. And then we'll divide that by 2. So 4 times 3 is 12. And 12 divided by 2 is 6. Okay, and now I don't have a unit of measure, so I'm just going to put units squared because it is area. So 6 units squared. Now, they're not always going to be asking you to find perimeter or find area. Sometimes it may just be as simple as what is the hypotenuse or what is the leg measurement.
Why did they call it a hypotenuse?
Because they like fun, funky names. I don't know. I can tell you the reason it's called Pythagorean Theorem is because it was founded by Pythagoras.
Who?
Pythagoras.
The Greek god? He's a god. He was a math god.
He was somebody who really wanted to annoy you. All right. Shh. Let's identify. How to identify if it is a right triangle, because you'll come across situations like that as well where you're having to state, okay, is it a true right triangle or not? So if I give you the measurements 18, 30, and 24. It's kind of similar to what we had done before where we said, oh, hey, the sum of the two smaller sides has to be larger than the third side in order for it to be a triangle. Now we're trying to figure out, is it a right triangle by stating, okay, if the sum of the squared values of the two smaller sides is equal to the squared value of the largest side. So first thing you need to do, identify what are your two smallest sides. 18 and 24, right? So that means that 18 and 24 are your legs. Those are your A and B values. 30 is your largest side. That's your C value. C is always going to be the largest. And all you have to do is check and see, okay, does the statement A squared plus B squared equals C squared stand true? So you're going to check 18 squared plus 24 squared. Does it equal 30 squared? So what's 18 squared? 324. You guys need to have those memorized. What about 24 squared?
576.
576. What's 30 squared? 900. And then what did we get if we add 324 and 576? 900. So in this case, 900 is equal to 900. So yes, this is a right triangle. If it's not equal, then it would not be a right triangle.
It's only the beginning.
Go ahead and identify whether this is a right triangle or not.
Do I still do it in pen?
Yes, you're supposed to work this one out by yourself, please. It does matter which one is C, yes. Remember I said it's the largest one. C is the largest value. You'll be fine. Huh? Huh? You don't. There's soy milk, almond milk. We drink almond milk in my house. All right, who could tell me, is it a right triangle or not? No. Lena? No. Thank you, Lena. Lena? No. Okay. It is not a right triangle. C is the value of 7. A and B are going to be the values of 5 and 4. So if we do 5 squared plus 4 squared, what's 5 squared? 25. What's 4 squared?
6.
And when we add those together?
41.
41. Okay. And then C squared, that's the 7 squared. What is 7 squared? 49. And 41 is not equal to 49. Since they are not equal to each other, this is not a right triangle. Is everybody clear?
Yeah.
It's pretty simple, nice good little intro to it. Tomorrow we'll get into some more concrete applications.
What the frick is